students, welcome to my channel. So in this video lecture, we are going to discuss remaining fields of TCP header. So firstly, watch part 1 and part 2 of TCP header. Okay. So now in this video, we are going to discuss various fields like header length, then we will be discussing push bit, push, urgent, reset, okay, SYN and FIN. These fields of TCP header we are going to discuss in this video. Okay, so firstly let's discuss header length. I already discussed this field header length in IP header. So the same field, the same concept which we discussed in IP header is going to be in the TCP header. This is exactly the same concept as we studied in the IP header. So what we studied in IP header, this header length field is actually 4 bits. Okay, this header length field is 4 bits, but the TCP header, the length of the TCP header lies in the range from 20 bytes to 60 bytes. The total length of the TCP header lies in the range from 20 to 60 bytes. Okay, because 40 byte field is optional in TCP header. So this is the minimum length of the TCP header and 60 byte is the maximum length of the TCP header. Okay, so this TCP header length field, which is of 4 bits, is not fixed. You know, it might change, it might vary according to the requirement. It is not that always it is going to be 20 bytes. Okay, sometimes it might be 20 bytes, it might be 32 bytes, 48 bytes. So as per the requirement, this header length field is actually dynamic. It is going to be changed every time. So that's why we need to mention the header length field value. Okay. So with the help of 4 bits of the header length, what is the maximum possible value we can have? Put all ones in the 4 bits. Okay. So if I am going to put all ones in the 4 bits, the maximum value which we can get is 15. Okay, the maximum value that we can have in header length field is actually 15. But if you look at this range, the total length of the header might ranges from 20 bytes to 60 bytes. With just 4 bits, we are not able to represent 20 to 60 bytes. With 4 bits, the maximum possible value we can have is just 15. So if you have to put 60 byte in header length field, you have to define the length of your header in the header length field. So the maximum value that can be possible of header size is 60 byte. So how we are going to place 60 value in the 4-bit header length field? Okay, so which concept we are going to use here is scaling factor. With the help of scaling factor, we are going to make balance between 15 and 60, the maximum size of the header. Okay, with just 4 bits we cannot represent 20 to 60 bytes. With 4 bits we can just represent 15 byte. But if you have to represent 60 bytes, bytes in the 4 bits header length. Header length is actually one of the field of the TCP header. In the diagram I discussed in the first part, header length is actually a 4-bit field. Okay, and we had a 20 bytes of TCP header and 40 bytes were options if you looked at the diagram. Okay, so now let's suppose we have a 32 bytes of the size of header. Now I have to keep this value in the header length field. Okay, I have to represent 32 value in header length field. So what I am going to do, I am going to divide it with 4. Okay, I am going to divide it with 4. Then what is the value we are getting? 8. Okay, and this 8 value is less than actually 15. This 8 value is less than 15. So we can keep this value in the header length field of the TCP header. Why do we need to place the total length of the header in header length field? Because we have to differentiate between the length of the header and the data. We want to know where your actual data is going to be started. Unless you know the header length, you cannot determine where your actual data is going to be started. Because if you look at in your TCP header, you have a TCP header, then data. Okay. If you know the length of the header, then you can determine that where your data is going to be started. So that's why we need to have a header length field of 4 bits. So it is actually we are storing 8 value in the header length field. We are saving value 8. But what is the original length of the header is 32. Okay. In the header length field, we are saving actually 8. Okay. But how we are going to get the original length of the header? By multiplying it with 4. We will be getting the original length of the header by multiplying it with 4. Okay, just to balance between these two values, the header length field value and the total length of the header, we are dividing it with 4. But when we have to get the original length of the header, we will later be multiplying it with 4. So that we can get the original value of the header. Okay. So this way we are going to determine the header length value. If you want to understand it better, you can also watch my videos of IP header. I have discussed this topic very clearly in that videos. Okay. So the next question is, if this is 32 bytes of data, but it is not that always you would be having 32 bytes of data. Let's suppose you have 34 bytes of data. Okay, the total length of the header is actually 34 bytes. So even if you divide 34 by 4, it is not completely divisible by 4. 34 is not completely divisible by 4. Okay, so what you are doing, you are actually getting floating number value. If you divide 34 by 4, you are actually getting floating value. What is the value you are getting? 8.5. But you can't keep this 8.5 value in the header length field of 4 bits. It is always going to store the integer value. It doesn't store the floating number value. Okay. But we can't place 8. We can't place the floor value. 8.5 floor value is 8. Okay. Because if you are doing like this, 2 bytes of your header, 2 bytes of your bytes of your header is going to be part of data. Okay, if you are taking 8 in the header length field, what does it mean? That the length of your header is 32 bytes. So the remaining bytes of these 34 bytes is actually going to be considered as a part of the data. So if you do like this, the original content of your message is getting disturbed. The original content of your message is going to be changed. So what we do, we always take the seal value. Okay, we always take the seal value. What we will do, we will be taking the 9. Okay, and what we will be doing, the 2 bytes of dummy bits, 2 bytes of dummy bits, we are going to add in the options field. We are going to do extra padding of bits in the options field. Okay, we will always take the seal value, and the 2 bytes of dummy data we are going to add in the options field. So this is the complete header length field. This is how header length field works. Okay, so now we are going to discuss the next field of TCP header. It is urgent. It is urgent field. What is the purpose of using this field? Let's suppose sender is sending some data to the receiver. Let's suppose this is your sender, this is your receiver. Okay, and we have a router present between sender and receiver. Okay, and sender is sending some data to the receiver. Okay, and we have some urgent data present within the message. What I mean to say, let's suppose I want to send some message to receiver. Okay, I am sending message, hi Neha, this is my email. Okay, what message I am sending? Hi Neha, this is my email. Okay, let's suppose abc@gmail.com. Okay, so let's suppose this is the message which I am sending to my friend. Okay, and if you look at out of the complete message, this email is the urgent data. You know, out of the complete message, this mail is the most urgent data. Okay, if you are going to send this data in a one particular sequence, okay, then your urgent data is going to be delayed. Okay, it will take some time to reach at the receiver side. So if you look at the complete message, the most urgent data you have is this email. So what I want to do, I want to send this email at the priority. Okay, I want to prioritize this email. I want to send this email faster than these 2 lines. Okay, I want to send this email faster at the urgent. Okay, so this is basically our urgent bit. What does urgent bit means? If you are setting urgent bit field 1, what does it mean? You have some urgent data present within your message. This is my one message, but within a message I have some data which is urgent, and I want to send that urgent data within my message at the faster rate. Okay, so in that case we actually use urgent field. Okay, so what would happen when this message or this mail is reaching to the router? Then what router would firstly check? Router would check the urgent bit. Okay, it would check if the urgent bit is set to 1. Then router would understand that okay, there is some urgent data in the message. Then what router would do? Router is going to fetch that urgent data of the message, and it is going to prioritize that data. Okay, it will send that data to the receiver at the priority. Okay, so that is the basic idea of urgent field.